called bisectors of triangles. So yesterday we talked about the perpendicular bisector, where we had the segment and we make the line that's perpendicular and a bisector. And then the other one we talked about was an angle bisector. So we did those two constructions with our safety-based compass. And then yesterday we talked about their theorem, right? How if you put a point anywhere on that line, it's equidistant from the sides. And if you put a point anywhere on the bisector of the angle, it's equidistant and perpendicular to the sides. Today, we're going to take it even further. So we're going to get something called the Circumcenter. And the Circumcenter is going to be when you have three perpendicular bisectors. All right. So when you have a triangle, you have how many sides? Three. And so with each side, you can make how many perpendicular bisectors? Three. So you could do one on this side, one on this side, and one on this side. So if we were to use our safety-based compass and construct three perfect perpendicular bisectors, those three perpendicular bisectors would all meet at a point in the middle, and they would be called the circumcenter. Okay? So we're going to pretend like we have our safety-based compass, and we're going to create a perpendicular bisector for each side. So if you had your safety-based compass and you made your arc up above and an arc down below, you would draw a perpendicular bisector. It'd be about like that. We'll put a little box to show that it's perpendicular. We'll put 2 tick marks to show that it bisects it. We'll call the endpoints A and C, and we'll call this midpoint F as in Frank. Okay? That's one. All right? Now you can either turn your paper, or pretend like your paper's turned and do another perpendicular bisector. So if we had our safety-based compass, we do our arcs, we draw our perpendicular bisector, it would look something like that. Okay? This third vertex up here we'll call B as in boy. This intersecting point we'll call D as in dog. And it is perpendicular as well. And it bisects as well. So we'll put double tick marks. Because that's our second perpendicular bisector. How many more do we have to do? One more. Okay, so we're going to go the third side of the triangle. And I find it just easy to turn my paper. And from each of the 2 endpoints, we're going to pretend like we do our arcs. We're going to draw in our perpendicular bisector. And then it's going to look something like that. We're going to put a little box to show that it's 90 degrees. And we're going to put triple tick marks to show that it bisects it. Okay? If you did it perfectly, you should have an intersection point in the middle, right here, where all 3 of them cross. That's called your circumcenter. And the circumcenter is the special word we learned yesterday. What's the special word we learned yesterday? Equidistant. Equidistant from all of the vertices. And underline the word vertices or highlight it. Okay? So from this point right here, we could draw in another line. I'm using my highlighter to show that that segment right there, this segment right here, and this segment right here, going to all 3 of those vertices, is equidistant. Okay, they're all the same length. So if one of them's 15 inches, the other one's 15 inches. One of them's 2 centimeters, the other one's 2 centimeters, okay? And what happens is you know your safety-based compass, you can put the little metal ring right there on the circumcenter, adjust your compass till one of these points shows through one of the little holes, and then you could make a perfect circle, and it would go through all 3 vertices, and that would be called circumscribed, okay? All right, and this point right here, that circumcenter, we haven't labeled this one either. This one is E as an elephant, and this one in the center is G as in gross one. Okay? So, if GB is 13.4 inches, then GC, bless you, is 13.4 inches, and GA is 13.4 inches. Those are to each of the 3 vertices. Please note that GF, so from here to here, is not determined. It has no special relationship. They may give it to you and they may tell you how long it is, but with the 3 perpendicular bisectors in the circumcenter, it doesn't have a special measurement. Okay? So you might get like a trick question on that. All right, so we are going to do an example. We'll call this example number 1. And you're going to take your piece of graph paper, and you're going to trace a rectangle around it. And you're going to write staple graph here, or tape it or glue it or whatever, okay? So we're going to find the circumcenter of triangle HJK. So I'm going to give you some points. H is at 0, 0. J is at 10, 0. And K is at 0, 6. So what do you think the first thing we need to do is? Graph these 3 points and label them. Okay? So H is easy. 0, 0. Right at the origin, right in the center. Okay? You're going to put a big point there. And next to it, you're going to write H. The next one is at 10, 0. So we're going to go 10 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Happens to be the last one over here. And call it J. And then K is at 0, 6. So we don't go any right or left, but we go up 1, 2, 3, 4, 5, 6. And that is K. So those are the 3 vertices of our triangle. So we're going to connect them all. So K to H, straight up and down. H to J is horizontal, straight across. And JK is diagonal. Just draw it as straight as you can. All right. So to get the circumcenter, we need 3 perpendicular bisectors. So bisectors, perpendicular bisectors, are going to go from the midpoint, and then they're going to go perpendicular. Okay? So when you have straight lines, whether they be vertical or horizontal, it's really easy to find the perpendicular line, right? It's just the opposite direction. So if one's horizontal, the perpendicular line is going to be vertical. If one segment's vertical, the perpendicular line is going to be horizontal. The ones that are going to be hard are the slanted ones, right? You'll have to count out the slope and then take the negative reciprocal. It's okay. you wrote it on the board, but we erased it. So, neat. Thank you. You're welcome. No problem. Okay, so we're going to do the perpendicular bisector of the two straight sides. Okay? Because if you see what happens up here, all three of the segments that we drew crossed at the same point. So technically, you only need to do two sides. The third one's going to cross at the same point. Does that make sense? Okay. So we're going to start with the two easy ones, and they should intersect at this Okay? So let's do side HJ first. How long is HJ? 10. Because that points at 0, 10. Sorry, 10, 0. Okay? So what's halfway? 5. So we're going to count over 1, 2, 3, 4, 5. And we're going to put a point. That's the midpoint. Okay? And because it's horizontal, the perpendicular line is going to be vertical. So I'm just going to go straight up and down through that point. And that's my perpendicular bisector. I can put the little box, I can put 2 tick marks, and we've got a perpendicular bisector. Okay? Now we could go to the slanted line, but this one's vertical. So it's going to be easier to do that one. So we're going to turn our paper this way. And how long is this side? 6, because that points at 6, 0, right? So halfway would be 3. 1, 2, 3, put a point. And since this line was vertical, the perpendicular bisector is going to be horizontal. So draw your little box to show that it's perpendicular. Put 2 tick marks. And then you're going to see real easily where those two intersect. They intersect right here. Okay? That point right there is what we call the circumcenter. Bless you. And we can count exactly where it's at because we're on a piece of coordinate plane, piece of graph paper. So it's at 1, 2, 3, 4, 5, up 1, 2, 3. It's at 5, 3.